In this video, we're going to look at how to solve nonlinear equations. So I'm going to start with a somewhat trivial problem that could very easily be solved using any basic amount of algebra. And in fact, it's going to be a linear equation, but I want to demonstrate the basics of how to use fsolve. So let's go ahead and import numpy as MP. And then we'll go ahead and import from scipy.optimize, we're going to import the fsolve function. And this will allow us to solve, given a function, roots that drive our function's value down to 0. Okay, so let's go ahead and define a function here. And let's go with something super simple. So let's go with photon energy. And we'll go ahead and give it some input z. And let's grab some constants. We'll say h equals, and this is can be 4.135, and it'll be in units of eV. This Planck's constant, and then c will be the speed of light, and we'll do that in units of meters per second. And now we're going to say E, the energy, is equal to z naught. So what we're going to be doing here is we're going to be putting in to this function an array or a list z, and the items in this array are going to be holding the variables that we're going to update in order to drive our equation solution to 0. Let me show you what I mean. The other thing we're going to want is, if we're going to do the photon energy, we're going to want lambda. This we'll say is equal to, let's give ourselves a wavelength, 525 e negative 9. So this is going to be in meters. Okay, and so finally, what would be our output? Well, if we think about this equation, we know E equals h nu, or E equals h c over lambda. So if we want to set our equation to 0, simply we can say our output f, or we can call it output, which is going to be 0. When our f solver is done, it's going to try to drive our equation's output to 0. It's going to be h times c divided by lambda minus e. So now we've made this equation equal to 0. And so we will go ahead and return our output. Okay? So now we have this function here where we're going to input a z as a list, and it's going to grab the first item of the list, and it's going to update this value e, and this is what fsolve is going to do. It's going to update this value e, or the first item in z, until it can drive this value to 0. In other words, find the solution to this equation that satisfies output equals 0. Now, it can do this for any equation, linear or nonlinear, and so it'll be particularly useful when we encounter nonlinear equations that you can't simply just solve. So let's go ahead and grab a z-guess. I'm going to go ahead and do this z-guess, and we're going to say it's an MP array, and let's guess e is 1 negative 4. Now this guess is important because your optimizer is going to start here when it begins exploring, and if your guess is incorrect, you'll either find different roots or you will fail to converge. And so let's go ahead and see if this is a good root. So we'll do fsolve, and this is how you're going to input things. You're going to get photon energy, so you're going to give it the entire equation without the argument, and you'll notice this value z, the argument to your equation, is what you're going to be updating using the fsolve function. And then finally, besides the equation itself, you'll give it a guess. And if we go ahead and run this, so we'll import numpy, we'll grab fsolve, which we're going to use to solve our equation. We'll define the equation, which takes an input z. Now the reason I write it this way, I'll cover that in a little while. We're going to define our equation. We're going to guess what the value e, the correct value, would be, and then we're going to let the solver update z, which is going to update e until this function outputs a value of 0, which means we have found a correct solution to the equation we have here. So we're going to grab this, and we're going to get a value of z, and we'll see z is the exact same value we input. Now let's change this to a -6 and see what happens. And I have failed. What the heck? That's unfortunate. What happened? I'm too tired for this.